Yes, let's try to understand what is stoichiometric. What do you mean by stoichiometric calculations? Stoichion is a Greek word which means element, and metric means measurement. So it's basically the measurement of elements. May not be elements. It will be to like the mass of an element, the volume of an element, or the number of atoms or molecules that are involved in a chemical reaction. So we are going to measure how much the mass, the number of molecules, or the volume of the reactants and products that are formed in a chemical reaction. We will measure how much reactant will be needed or how much product will be formed in a chemical reaction. So in order to know that, that is called stoichiometric calculation. So we will given some kind of some reaction, and we will try to find out, or we'll try to measure. Metric means measure. We will try to measure the the amount of products formed or the amount of reactants needed. And for that, we need to understand what are the information that are provided by a chemical reaction, and that to a balanced chemical reaction. So let's consider an example. This is methane. Methane, when burned, it forms carbon dioxide and water, that we know. Just like the gas that we're using, it contains that also contains maybe some amount of methane, but it's largely propane and butane. So when they are burned, it forms carbon dioxide and water vapor. So nothing is left. So when you burn the gas, nothing is left. It means it has turned into carbon dioxide and water. So this is a chemical reaction for that. That is going on every day in our kitchen, right? So methane, the formula is CH4 plus oxygen, because we know that burning requires oxygen that is present around us. So oxygen, it forms carbon dioxide and water vapor. Both of them are not visible because they are gases. So what happens is, when you write a chemical reaction, the the things that are on the left side of the arrow, they are called reactants. They react, and after reaction, what they form is written on the right hand side, and those are called products. So here, these are the methane and oxygen are the reactants, and carbon dioxide and water they are products. So reactants are on the left side, and the products are written on the right side. And these are the formula. The molecular formula of methane is CH4. Oxygen is also known as dioxygen, that we breathe, that is present in the atmosphere. Some 21% of the volume of the atmosphere is oxygen. So oxygen is written as O2, carbon dioxide is CO2, the molecular formula, and water's molecular formula is H2O. All of us know. And so what we have done first, after knowing that these are the reactants and these are the products, we need to balance the reaction. So what do we mean by balance? It means that the number of atoms that are on the left hand side of the and that on the right hand side means reactant and products, that must be sum. And it's according to the law of combination that we have studied earlier, which says that nothing, um, no, we cannot, the the entire thing in the universe is conserved, right? The number of atoms in a chemical reaction, no new element, no, there will be no new element. Whatever elements are there, whatever is there, it will be just, uh, there will be, the mass is conserved. What is being used will be formed. That the total mass of the entire system will remain constant. The mass will remain conserved, or the number of atoms on the left hand side should be equal to the number of atoms on the right hand side. So we find that CH4, here we have one carbon atom. Here is one carbon atom. And oxygen, hydrogen, there are four hydrogen atoms. Here there are two hydrogen atoms. So hydrogen is not balanced. So we'll start from hydrogen. In order to balance the hydrogen atom, what we'll do, we'll make it these two atoms four, because here we are having four. So let's make this four. How will we make this four? Put a two before water. So it becomes, write two. When you write two here, hydrogen becomes four. Here it's balanced. What about the oxygen? Let's count oxygen. Oxygen, here, how many oxygen atoms are there? There are two. And here also there was one, but we put two before this, so this two is for this oxygen also. So there are two oxygen atom. Two plus two, there are four. And on the left hand side, there is only two oxygen atoms. So in order to balance it, we put a two, a coefficient, before the oxygen. So it becomes 2. So 2 twos are 4. So now I think now all the atoms are balanced. Carbon atom is balanced, hydrogen atoms are balanced, and oxygen atom is also balanced. So we have a balanced chemical reaction. So let's see what are the information provided by it. So before what we have before the numbers that we are writing before the compounds or the elements, they are coefficient, or they are also called stoichiometric coefficients. So here we have 1, here 2, 1 and 2. So it first of all, it gives the number of molecules that are reacting. One molecule of methane is reacting with two molecules of oxygen, two molecules of oxygen to give one molecule of carbon dioxide and two molecules of water vapor, right? How do I know this is water vapor? Because inside the bracket we write G, that means gaseous state. It may be aqueous state AQ, it may be solid. If it's solid, then we write S. If it is a liquid, then we write L. So these are all the reactant. In our case, all the reactants and the products are in gaseous state. You know that through the symbol that we're using, G, 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 right? So first we know the number of molecules. So one molecule of methane is reacting with two molecules of oxygen to give one molecule of carbon dioxide and two molecules of water. Similarly, that would be dozen. One dozen of methane is reacting with two dozen of oxygen, is reacting with one to form one dozen of carbon dioxide and two dozens of water molecule. That means, in other words, let's remove the dozen, let's use mole. 1 mole of methane is reacting with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water, right? Now, 1 mole of substance, we know the methane's molecular mass is 16 U, so it will be 16 gram. Similarly, oxygen is 32, 2 multiplied by 32 to 64 gram. It will be 1 mole of carbon dioxide is 44 U, the mass 44 U, so its molar mass is 44 gram. 1 mole of water is 18 U at one molecular mass, so its molar mass is 18 gram. So 2 into 18 gram. So what we have got, 16 gram of methane reacts with 2 into 32 gram of 2 multiplied by 32 gram of oxygen, or 2 times 32 gram of oxygen to form 44 gram of carbon dioxide and 2 times 18 gram of water, right? Suppose this reaction is going on in a fixed temperature and pressure, and at that fixed constant pressure and temperature, the volume of methane is 22.7 liters. So we can say there's 1, so 22.7 liters of methane reacts with 2 times 22.7 liters of oxygen to form 22.7 liters of carbon dioxide and 2 times 22.7 liters of water. So first we have got in terms of numbers, molecules or moles, then mass is there, then it gives information regarding the volume if you're considering volume also. So in a balanced chemical reaction, when it is balanced, we find that it gives many information. It gives information regarding the number of molecules that are involved of reactant and product, number of moles and mass, and if it is happening, it's conducted in a specific temperature, in a fixed temperature and pressure, then we also know the volume of the reactant and products. And what is about this volume, I will tell later on that why. But now I'm thinking if its volume is supposed to some x liter, then it will be 2 times x liter, and its volume will be again x liter, and the volume of water will be 2 times that x liter at that particular temperature.